Today I will talk about technology clusters, which is a project organizational approach aiming at achieving 3 to 0. 0 accidents, 0 delays, and 0 defects. Professor Colin Gray from the University of Reading developed technology clusters approach that was adopted on some iconic buildings in London. Also, from observing the industry, we found that out of necessity, most complex buildings projects have taken similar approaches to their project organization, albeit in later stages of their projects. What we are promoting is a clear commitment from the outset of the project to a fully integrated project organization to eliminate problems and achieve effective communication and collaboration from the start of the project to the end. So let us first discuss the issues of communication and collaboration on construction projects. Project team is a term to describe the fact that the design and construction processes require inputs from a wide range of contributors and organizations. The key issue is how to integrate these multi-organizational, multi-professional teams with different organization structures, different cultures, different languages, example industry jargons, etc., into one integrated project organization, where people communicate easily with no misinterpretations or misunderstandings. The group needs to exchange skills and knowledge, but within a temporary and changing multi-organization. People are in and out at various stages of the project. Therefore, teamwork in the conventional sense will not occur. This has big management implications because the assumptions associated with teamwork are not valid in this temporary and changing multi-organization. The contributors to a project are a network of different organizations selected because of their knowledge, skills, and manufacturing capabilities. There is the need to understand this network of communications. What are the outputs at this stage, and who had the right skills and knowledge to contribute to the process for achieving these outputs? Who should contribute what, when, and at which level? Organization charts do not show this network of communications. Organization charts provided by each organization when appointed to the project concentrates on the vertical communications within the organization. This is not sufficient because the horizontal links between organizations are not clear and confused. In addition, these organization charts often use different terms to describe roles and responsibilities. Example, some organization chart might use the term foreman, while another organization might use the term key supervisor, or a construction manager who is in fact at the level of a site manager in other organization. Furthermore, these organization charts include people that are not involved in the problem-solving process of the project. Example, BIM operator or commercial manager of an STC. Assuming we have two organizations, A and B, it is not clear who from Org B should work with someone from Org A on a design or construction problem. In any project, there might be over 30 organizations that should communicate horizontally. As a project manager, you need to draw your project organization out of these various organization charts, putting people at their right position in your project organization and using consistent terms in assigning their roles. In this way, when inviting the team for a problem-solving situation, you know who should be there and make sure the STCs cover these roles in their contribution to your project. A project generates a core team of architects, engineers, and key consultants. Given their long-term involvement in the project, they will develop synergy of views and understanding of each other, reaction to proposals and ideas. In practice, this takes between 6 to 9 months before full understanding and trust occurs. As the project develops, others are added to this group and will become involved for shorter terms and specific contributions. The core team, therefore, has tremendous power through its long-term knowledge. This power of knowledge makes it difficult for the newcomers, particularly the STCs, to have their saying. STCs might have better solutions to some design problems or better understanding of the buildability issues. And let the managers take over the management of the process from the core team at the right stage of the project, the STCs might not be able to contribute effectively their knowledge and skills to the project. The project manager should recognize this and update the project's organization at key stages in the process. We looked at the key communication issues on a project. Let us now look at the collaboration issues. Professionals and specialists cannot work in isolation. They need to be brought together to achieve a product that is the combination of their skills and knowledge. The management task is to provide a collaborative environment to allow for this transfer of skills and knowledge. On a project, some people's contribution lasts a long time, others for shorter time. People will be frustrated if they are expected to work as a team, but their contribution is unrecognized at the end of an intensive period of work. In addition, for a group to collaborate, they must have shared and clear goals that unify their activities. Collaborating groups must have a joint commitment to these goals. Language can be a barrier. One typical problem is the use of jargon or metaphors that are difficult for others to understand. Architects can easily fall into this trap as they talk about the underlying social and environmental philosophy of technical issues. A chain is only as strong as its weakest link. The level of understanding of the detail must be as high as possible. Therefore, each contributor should provide the best people from the organization into the project, or increase the learning of the organization to provide the necessary inputs. Collaboration requires people to work together to their maximum potential. This can only happen where there is trust and respect for each other's capabilities. The management must provide this type of working environment for each collaborating group. Collaborators are constantly reacting and responding to each other, and frequency of contact becomes almost as important as the nature of the contact. Formal communication is continual through, for example, fortnightly meetings or issuing of information, etc., while informal communication could be continuous. Successful collaboration must allow the continuous exchange of information and knowledge without having any barriers in the way. There should be a clear lines of authority and formal communication rules, but no restrictive boundaries, so that the communication can flow informally and freely between organizations. Therefore, the issue of communication and collaboration is an issue of organizational design, where the structure of the relationship should allow good communication and collaboration between the people at various levels. So let us now see how people communicate and collaborate at various levels. So let us look at some concepts for better understanding of the issues that cause often confusion, misunderstanding, and break in communications. Project development requires the input of specialist knowledge that must be communicated by people working at the same level of integration. The distinction between these levels is based upon two factors: the level of abstraction of the work that a person is capable of achieving, the time span that a person has control. People at a higher level have a greater degree of abstraction, and their time span of control is longer. For example, a project director will be talking about strategies, plans, etc., and their control spans over the whole duration of the project. While a bricklayer is concerned about the tool, the mortar, the drawings, etc. They control the area they work at, and their control finishes once they finish laying the bricks in the area. The talk about strategies, visions, etc. does not mean anything regarding their work. Besides, they do not have a saying in these issues. On the other hand, the project director would feel frustrated if they have to sort out a bricklaying problem. They might not even have the detailed knowledge needed to do that effectively. These are extreme examples meant to explain the idea of levels. However, in reality, the little difference between the levels will cause problems and confusion if not understood and addressed. For people to do their tasks properly, they need to have a manager working at the level directly above their own to give them directions and support. Example, the foreman of the bricklayer. In other words, gaps in the structure of levels cause problems of understanding and communication. People from different organizations who are at the same level are largely dealing with the same issues. Therefore, they can collaborate and make decisions without problems. Confusion and problems occur when communication is forward diagonally across levels between two organizations. When there is an integration gap, individuals at different levels are required to work in lateral relationships. Those at lower levels do not get management and direction from their own higher levels, but inappropriate direction and demands from higher or lower levels in other organizations. An example could be a junior architect at a meeting with engineers and specialist trade contractor project managers when decisions are to be made about alternative solutions or systems. The junior architect does not have the knowledge or the authority to contribute to the decision-making process. The only thing they can do is take in notes of the meeting and go back to their seniors for the decision to be made. Consequently, the meeting is not effective. To create an integrated project organization, the project manager should explore the connections between the different participants in the process and make sure these connections are compatible. Let us see now how this integrated project organization might look like. This diagram shows the various roles in a typical project: the client, the designers, the managers, off-site and on-site, and the STC's designers and teams on-site. Each of these roles might be one or more organization. At later stages of a project, for example, there might be 30 or more STCs involved. The diagram could be used as a template to help the project manager to identify and assign clear roles and responsibilities to the project team, making sure that instructions do not cross levels and organization boundaries at the same time. The arrows A, B, C, D, and E are the interfaces between firms that should be at the same level of integration, so that all individuals approach the problem at a similar level of awareness and decision-making ability. The diagram identifies 7 levels of integration from site operations, i.e., the team responsible for construction on site, up to the strategic level, where people are concerned about what the project should achieve in terms of the client business. This diagram does not include everyone connected with the project, but is a representative of the types of relationships that need to be established when creating a project organization. The management role shown here can be provided by one or more organizations at various stages of the project, depending on the project size and complexity. We might have an organization managing the client's business related to the project, another one covering the off-site roles, and an organization covering the on-site roles. Or we might have an organization covering off-site and on-site roles. In addition, for each organization involved, the roles shown here should be covered regardless of the people covering them. For example, you might have the same person covering the roles of the site manager and the foreman for the ducts installation. These roles might be covered by 2 people for the steel frame installation STC, while you might have a few team including site managers and foremen for the electrical installation STC. As the project manager, you should know who is doing what and ensure there are no gaps in your project organization so that no diagonal communication happens, causing confusion. Coordination will occur within organizations and between them to achieve the requirements of the project. The manager should lead the process and manage the interfaces between the various organizations involved at each level of integration, as the arrows A, B, C, D, and E show. The identification of the issues to be coordinated and the timing of the coordination should be driven by the managers of the process. Leaving, for example, the coordination to the STCs to sort it out, regardless of what their contracts might say, is not good management approach. As a manager of the process, it will not look good for the client if you have to knock down a wall or return back products that did not fit with the rest. Just pushing the blame is not going to sort out the problem. The interface marked A at level 6 is about understanding what the project is going to achieve in terms of the client's business. The project director can supply their particular expertise and can convert the client's expectations into an achievable direction. At this level, the strategic brief, the outline design, the cost plan, the strategic program, and procurement strategy are developed. The interface marked B at level 5 is about developing the project plans such as cost plan, design and construction programs, and procurement plan. i.e. the overall direction set at level 6 above is converted into specific goals and plans. The system to be developed and the resources to be deployed over the life of the project are discussed at this level. At the interface marked C level 4, the discussion between the designers and the key STCs is related to developing and coordinating the scheme design. Each STC organization had a specialized input of either overall system, as in the case of the M&E STC designers, or particular systems, such as the firm supplying the lifts installations. Therefore, they have to be able to discuss issues with the architects and engineers as colleagues, all working in the same way. Also, each contributor would delegate work to their level 3 detailed designers to produce the detailed design. Feedback from the industry shows that the lack of coordination at this level is always the problem, because the STCs are not involved as early as they should. Therefore, the designers either progress the design based on assumptions or they leave gaps in the design until the required inputs from the STCs are available. The interface marked D at level 3 is about developing the project detailed design and production information, cost plan control, and detailed programs. At this level, the design produced will be used directly by manufacturers and construction teams and should ensure that the construction work achieves the required standard. Level 1 and 2 are the construction stage, when the design is realized and needs fully coordinated production information. Gaps at the earlier stages will severely compromise the ability of the construction teams to work well. Missing, inadequate, not buildable, or not coordinated information will cause interruption to site activities, as the teams have to stop, waiting for the problem to be sorted out. The project manager is responsible for developing this integrated project organization for effective communication and collaboration. By adopting a structured approach to managing the design and construction process, interpretations and ambiguity in expectations would be avoided. Now I'll share with you an example of some of the interfaces that need to be managed and coordinated on a typical project. A few years ago, I investigated the number of drawings produced for the building shown here. Although it looks spectacular, but it is still a typical high-rise office building with repetitive floors, i.e. the construction industry is used to build this kind of office building, and yet it needed about 18,000 drawings. Almost half of these drawings were original, as the iterations are 38% of the total number of drawings produced. The architects and the engineers produce about 36% of the drawings, and the STCs produce the remaining 64%. You might say the STC's drawings are usually a little detail here or there, but at the end of the day, a little detail will stop the whole area and interrupt the site activities if it is not produced and coordinated on time. The chart at the top is the strategic program of the project. The yellow bars are the design activities, the green ones are the construction of the structure, the pink and purple are the M&E installations, the rosette is the lift installation, and the light blue are the facade. The bottom chart shows the number of drawings produced by the designers and the STCs per month. Here we can see that when construction started on site, only 3% of drawings were produced. 65% of the drawings were produced after the M&E installation started. This chart also shows the extent of the STC's involvement in the design. We can see that during the information production stage of the project, the number of drawings produced by the STCs peaks, while the number of the drawings produced by the architects and other consultants declines. At the beginning of the M&E installations, the number of drawings peaks for all involved. The final peak is the facade line. This is because of the installations of the retail areas at the ground floor and the first floor. Here are the drawings iteration and finalization patterns. The iterative loop is very active at the production information stage and continues well into the construction stage. The second chart shows that the number of finalized architectural drawings peaked sharply 4 months after the M&E installation started. This peak is 8% of the drawings, which is about 200 drawings in 1 month. This is probably because the architects completed the drawings after the M&E and lift STCs provided the necessary information. This study only looked at one type of information transfer and interfaces between the various organizations involved in a typical project. The number of drawings were about 18,000, not to mention dealing with the daily stream of requests for information RFIs and requests for change RFCs. This is what the managers of the process need to understand and manage to achieve 3.0. These graphics remind us with the roles of the various contributors to the design and construction process. Designers, when developing the project brief and progressing the design, they in fact utilizing their creative skills to set the value requirements of the project that should be conveyed to the team and maintained throughout the process. This is a very complex process, as the stakeholders, whether external to the project such as the users or internal such as the client, the funders, and the STCs, are many with conflicting interests. Technological excellence is in the design and manufacturing of building components. The STCs and their complex networks of subs, suppliers, and manufacturers contribute to the design, provide the building components, and build the building. Achieving 3.0, i.e. safe, timely, and quality production on site, is dependent on the details of the design. Inadequate design information, buildability issues in the design, or changes during the construction stage will cause interruptions, delay, and all sorts of problems. The roles of these four groups should be understood, and the right project organization that enables their contribution at the right time and at the right level of integration should be created as we discussed earlier. However, it is necessary to design a project organization that breaks down the complex setting in a way to focus the management efforts on the key issues. In the second part of this lecture, we will talk about such an organization. So let us now have a little break and reflect on the following, taking into account your background and experience. See you in the next part of this presentation.